When we simplify radical expressions involving addition and subtraction, we basically add the coefficients in front of the radicals if the radicals are like radicals. In my example, I have 3 root 2 plus 4 root 2. The radicals are the same, so they're like radicals, so I can add the coefficients of 3 plus 4, keeping the root 2. Mathematically, this is sound because I could factor the square root of 2 out of each of these two terms, leaving me with the sum of 3 plus 4. And then if I simplify 3 plus 4 to get 7, I have 7 root 2. This should also look familiar to you in working with variables such as 3x plus 4x, in which we can combine like terms to get 7x. So it's a very similar idea. In this section, we're going to have problems that need to be simplified first. The radicals need to be simplified before we can combine the like terms. Before we get into that, let's also look at subtraction. 6 root 3 minus 2 root 3. In this case, again, I have like radicals, so I can combine the coefficients of 6 minus 2 to get 4 root 3. Also, if we have radicals that are not like radicals, in this case 5 root 2 plus 4 root 3, I cannot combine root 2 and root 3 with addition, so this is already in simplified form. This would be similar to an algebraic expression 5x plus 4y, in which we don't have like terms, so we cannot combine any terms. Let's look at an example with radicals that are not simplified yet. The square root of 125 plus the square root of 45. Looking at them as they are, we cannot combine them because they don't look like they're like radicals. So let's simplify each one of them. And in this lesson, I'll simplify by recognizing the perfect square or the perfect radical in each one. In this case, the perfect square that divides into 125 is 25. And the imperfect part would be 5. So square root of 25 times square root of 5 to equal square root of 125. Square root of 45 can be broken down into a perfect square of 9 times the square root of 5. If I simplify the perfect parts, square root of 25 is 5, and the square root of 9 is 3. I have like radicals, so now I can add the coefficients in front of the radicals, 5 plus 3 to get 8, square root of 5. Let me give you a practice problem. Four square root of 50x minus 6 square root of 32x, involving some variables too. In this problem, simplify each radical, combine like radicals. Turn off the video now and come back to it when you want to check your answer. Once again, in simplifying the radicals, I'll simplify them by recognizing the perfect square that goes into each one of these radicals. In this case, the square root of 50 can be broken into 25 and 2, square root of 25 being the perfect square. X is not a perfect square. I have to put it in the imperfect square part. I'll do the same for 32x. 32, a perfect square that divides into 32 is 16 times 2. The x is not perfect, so it goes in the imperfect radical. If I simplify square root of 25 and simplify the square root of 16, simplify the outsides of the radicals, 20 root 2x minus 24 root 2x. Now I have like radicals. I can subtract the coefficients 20 minus 24 to get negative 4 root 2x, and I've simplified the original expression. Let me give you one more practice problem. The cube root of 54 minus the cube root of 128 plus the cube root of 250. Turn off the video, come back to it when you want to check your answer. In this problem, once again, I'll simplify each radical by recognizing the perfect cube that goes into each. In the first, the perfect cube that divides into 54 is 27. 27 times 2 to get 54. In the second, the perfect cube that divides into 128 is 64 times 2. And in the third, the perfect cube root dividing into 250 is 125 times the cube root of 2. If I simplify each cube root, 3 cube root of 2 minus 4 cube root of 2 plus 5 cube root of 2, I have like radicals, cube root of 2 in each case, so I can combine my coefficients of 3 plus 5 to get 8, minus 4 to get 4, cube root of 2. Once again, in this lesson, we were taking radical expressions or expressions involving radicals, expressions that were addition and subtraction, simplifying each radical first, and then identifying if we have like radicals, and if we do, then we can combine them into a single radical.